periodic properties. This the properties which are directly or indirectly related to their electronic configuration and show gradual change when we move from left to right in a period or from top to bottom in a group are called periodic properties. Okay, the properties which are directly indirectly related to their electronic configuration and show gradual change when we move from left to right in a period and top to bottom in a group are called periodic properties. Such properties show variation with change in atomic number. Some important chemical properties exist in periodicity or periodic properties are electronic configuration, ionization energy, electron affinity, electronegativity, metallic character, nature of oxide, oxidation state, reducing character. Specific heat refractive index are not periodic properties. Okay, this the ionization energy is the periodic properties. Electron affinity is the periodic property. Electronegativity is the periodic properties. Okay, electronic configuration, metallic character, covalent or non-metallic giant. These things also periodic properties. Okay, we know this solid lattice. Lattice means, do you know lattice? What is, do you mean lattice? Do you know any? Have you any idea about lattice? Have you any idea about lattice? No. Lattice have regular arrangement of particles. Regular arrangement like regular arrangement. These things. I didn't make my blackboard today. I shouldn't. I so far haven't used these things. My blackboard, and it should be this one. What is this? These things. Okay. No. It should be black, and this one should be and my pen. Okay. Acha, which one is the regular arrangement? Do you know how do you understand the regular arrangement? Like in a building has 5-story building, and 5-story buildings like in the first ground floor. Ground floor contains like ground floor contains 10 particles, like 10 particles here, like 4 particles, 4 substance, another anything. This and first floor also here like same 4 things, 4 things. Then second floor also these things, like as third floor and fourth floor. This way the regular arrangement, same pattern, same arrangement of positive particles and negative particles. This is called lattice. Okay, this is the regular arrangement of particles form lattice. Okay, these things, have you understood what is lattice? What is this? What is this? What is this? Which things have I opened? I opened this another topics. Okay, type of solid lattice. There are 4 types of solid lattice: giant metallic lattices, giant ionic lattices, giant covalent lattices, discrete or simple molecular lattices. Okay, giant metallic lattices means metallics. How metallic bond is formed? Do you know how metallic bond is formed? Say, metallic bond form. What is metallic bond? The attraction force of positive nucleus and surrounding by electrons is called metallic bond, and there is formed the giant structure is formed when the particles linked many particles is formed bond. It is called ionic metal structure. Ionic lattice when form positive and negative. Biplab bhai, wait. These things from current page. Okay, this is the ionic that sliding is transition is problem making. Giant metallic lattice, giant ionic lattice, giant covalent lattice, and discrete means simple molecular lattice. Okay, look, it is disturbed. Ionic lattice, giant ionic lattice, sodium chloride. Covalent means simpler molecular or giant covalent. Covalent bond 2 types form 2 types compounds: simple molecular and giant covalent diamond. Giant covalent. Giant simple molecular means water. Giant covalent, example diamond. Here is a in the simple moleculars the bond is formed by covalent bond, and there is a small strong intermolecular. Here is present only a weak intermolecular forces. In a giant covalent structure, bond is formed by covalent bond by the atoms are this compounds molecules are joined by a lot of molecule joined by linked. This is the giant metallic. This form metallic structure bond is formed between positive nuclear charge ions and negative charge ions. Okay, I am discussed. Look at metallic lattice. Metallic lattice. Are you watching my screen? Not. Yeah, this is very bad. Now you are watching my screen. Are you watching? Okay, metallic lattice are composed of regular arrangement of positive metal ions, cations, and surrounded by delocalized electrons. Okay, metallic lattice have high melting and boiling points, good electrical conductivity, good thermal conductivity, malleability, ductility. Okay, this is the regular arrangement of positive metal ions and surrounded by delocalized electrons. Now giant ionic lattice. Giant ionic lattice are composed of regular arrangement positive and negative ions. Here is a negative and positive and negative ions. And metallic lattice is metal ions and electrons. Metallic lattice is from metal ions surrounded by delocalized electrons. Here giant ionic lattice is formed by positive and negative ions, regular arrangement of positive and negative ions. Okay, they have high melting and temperature, brittleness, poor electrical conductivity when solid, but good when molten, often soluble in water. Next is giant covalent lattice. Giant covalent lattice are sometimes called network of covalent lattice. They consist of giant network of atoms linked to each other by covalent bonds. Here atoms are linked together to each other by a covalent bonds. Diamond, graphite, graphenes. Okay, structure diamond. This is the giant covalent lattice. This thing is not your today's topics. Structure of graphite. This is not your topics. It will be discussed later. Our topics now. Graphene is not our topics. Today's topics. Okay. Now molecular solid. Molecular solid also is called discrete. Molecular solid will generally have low melting point and boiling temperature. In order to melt a molecular solid, it is not necessary to break the covalent bonds within the molecules. It is only necessary to overcome the intermolecular forces of attraction. Okay, there is don't need to break the covalent bonds only. Only it is necessary to overcome the intermolecular forces of attraction. For these reasons, this molecule have low melting point and boiling points. Okay, as a number of atom increases, their molecular intermolecular forces increases. Like ethane, intermolecular forces tend to increase in both increase in number of electrons per molecules, also increase the length of molecules. This means that the macromolecular solids such as polythene will have much melting temperature than its monomer. When the number of size increases, they are in macro simple moleculars, they becomes higher melting points. And so how can we predict the substance? This the metallic giant is magnesium, aluminum, copper, zinc. Ionic giant is sodium chloride, magnesium oxide, cesium fluoride. Covalent is two type. Covalent giant covalent lattice, diamond, graphite, silicon dioxide, Bn. I don't know this is. Okay, molecular lattice, molecular covalent, water, these things, glucose, sucrose, phosphorus, sulfur, iodine. This macromolecular, polymers, polythene, protein. Okay, this is the type of bonding structure. This is your later topics, but I am discussing because today's I need predicting physical properties. How can we predict the physical properties of a substance? At first I will do, does the substance conduct electricity when solid? If we question, you make a question, does the substance conduct electricity when solid? If solid, in a solid type it conduct electricity, it will be metallic bonding. Like if you take the iron, steel, aluminum pot, in a solid state it conduct electricity, so it is metallic bonding here is present. If no, it will be either ionic or covalent bonding. Then you will ask another question, does the substance conduct electricity when molten? If in a molten, the molten means liquid state, like when solid melt, this is the form state, this is the molten state, solid melts. When in the substance in a molten state conduct electricity, yes, is it ionic bonding. Here form giant lattice. If no, it will be covalent bonding. Okay, then you will ask a question, does the substance have high melting temperature? If yes, giant lattice. If no, molecular lattice, molecular substance. Okay, now our topics, today's topics. Today's topics is these things. I have already finished these things. To make you understand these things, melting and boiling temperatures, periodic properties. Today's topics, already I finished these things. periodic properties. Atomic radius already done last classes, and ionization energy, atomic number, atomic radius done, and today's melting and boiling temperatures. Like period 1, period 2, period 2 elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Type of bonding: in a lithium, bonding is metallic, structure is giant lattice. Beryllium, metallic bonding, giant lattice. Boron, covalent, giant lattice. So there they have high melting and boiling points. Like carbon, diamond carbon, covalent, giant lattice. Nitrogen is a simple molecular, covalent, so lower melting and boiling points. And oxygen, simple molecular, covalent. Only intermolecular, simple intermolecular forces, if break, this bond will break it. Okay, here this the fluorine is covalent, simple molecular, so their melting point is low. Type of bonding: the period 3 elements, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Type of bonding: sodium is metallic, giant lattice. Magnesium, giant lattice. Aluminum, metallic, giant lattice. Silicon, covalent, giant lattice. This is the phosphorus, simple molecular, covalent, simple molecular, oxygen, sulfur, and chlorine is simple molecular. So we have seen here the from left to right what is the periodicity change, what is the trend find. We may have noticed that elements with giant lattice structure have high melting and boiling temperatures. Those with simple molecular structure have low melting and boiling temperatures. Okay, we'll reason the explain in the we'll explain the reason for this in topic 3. Okay, I have already shown topic 3 reason. What is the reason? Okay, this thing will explain again. Now here is the periodicity, the ionization energy. Ionization energy in a period, ionization energy from left to right is increases. Like this is the period 2 elements. These are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Their ionization energy from left to right increases. Why this is increases? Okay, give me a question answer. Who can give answer the why ionization energy from left to right increases? Priyanto, there is no, you have no headphone. May I know, sir, what are you doing? Tamara can say, why does ionization energy increases from left to right? Why does ionization energy increases from left to right? Look, this is the lithium and lithium, then beryllium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and which one is fluorine, then helium. No, fluorine, this one. Last is helium. Why ionization energy increases from left to right? From left to right, why ionization energy increases? Tamara say, why ionization energy increases from left to right? Because nuclear charge increases. When we move from left to right, nuclear charge increases. What charge increases? What charge increases? Nuclear charge. Nuclear charge increases. If we move from left to right, shell number remains same. Shell number remains same, but when we move from left to right, number of electrons added. As a result, positive protons also added. So attraction force between nucleus and electrons increases. The attraction increases from nucleus. From left to right, when we move, shell number remains same, but electron number increases from left to right. As a result, the attraction force between positive nucleus and electron increases. More number increases means attraction force more means substance become compressed. Joto attraction hobe toto choto more attraction, so electron cannot be loose easily. Ionization energy, nuclear charge increases means so electron cannot be removed easily. A lot of energy is required. For these reasons ionization energy increases. যারা ক্লাস মিস করছে এরা কিন্তু অনেকটা বুঝবে না কি বলতেছে। But there is some irregularities here. Have you seen some irregularities here in the ionization energies? Like this lithium, then beryllium increases, but boron decreases. Why this decreases? Boron. Can you say beryllium and boron? It is increases, again beryllium decreases. Can you say why this one does decreases? Beryllium and boron. Look, have you any this the anomalous beryllium? Beryllium is electron number is 4, 1s2 2s2. Boron 1s2 2s2 2p1. Here 2s orbitals, 2s orbital is the fully filled. We know the fully filled is more stable. So more stable means lot of energy is required to remove electrons. So beryllium is more ionization energy than boron. Look, this beryllium is more ionization than boron. Again ionization energy increases carbon than nitrogen, and nitrogen and oxygen there is a anomalous. Like nitrogen electronic configuration is 1s2 2s2 2px 2py 2pz, and oxygen 1s2 2s2 2px 2py 2pz. But nitrogen here is a nitrogen in the outer 2p orbital 3 electron, and here is a p orbital 2p orbital 4 electrons. So here electron 2p 3. Nitrogen 7 electrons. 1s2 2s2 2p3 and oxygen 8 electrons. 1s2 2s2 2p4. Okay, Tamara, can you say how many electrons can occupy p orbital? Highest electron p orbital can occupy highest electrons. P orbital can electron occupy, how much electron can occupy? How many electrons can occupy p orbital? P orbital, s orbital, how many electrons can occupy? Highest electron. D orbital. Okay, Mehrun se bolo, s orbital can how many electron can occupy? Hey, s orbital can highest electron 2, and p orbital?
So p orbital 6
6 electron, and d orbital highest 10 electron. So here in the p orbital half filled, 3 means half filled. If p6 or p3, this is the half filled, and full filled are more stable. So this is the half filled, so the more stable. Here is p4, it is neither full filled or nor half filled, so it's the less stable. This is the more stable. For this region nitrogen is more stable. For this region it required more energy to remove one electron, so it has more ionization energy. So nitrogen is more ionization energy than oxygen. Then fluorine, neon. Neon is the octet full and more stable. The noble gases, electrons to remove electron from the outermost shell require a lot of energy. So noble gases have highest higher electronic ionization energy. Okay, so topics is done. Approximately look this thinking bigger. Topics 2 finishes. Have you seen? Topic 2 done. Now next day is your exam need to be held. Look, exam practice. So how will approach the exam? How do you approach the exam? Will I take this exam on the when will I take this exam? Next week is 15 November, 15 February. 15 February will I take exam, or how will I take exam? The exam will be held. This is the topic 2. Say less than 1 minute is remaining. Quickly. Huh?
Like